All right, good afternoon. It's a pleasure to be back at Rise. My name is David Chen. I'm from a company called Skycatch. And if you're not familiar with Skycatch, what we are is a startup from San Francisco, and we build hardware and software for 3D mapping using drones. I've been with the company for over 4 years now, and in that time, I've seen drones go from just a simple camera in the sky controlled by a human operator to a fully autonomous aerial robot that can capture and perceive the world in ways that humans can't and improve everyday life and work. So today, our products are used by some of the world's largest companies across thousands of construction sites in the world. In the US alone, more than half of the top 20 construction firms employ our technologies to make their job faster and more efficient. Recently, we started fulfilling a delivery of 1,000 drones for Komatsu, the second largest manufacturer of heavy equipment. This was the largest commercial drone deal ever made. It's not an easy road to get to where we are today, and in 2015, strict regulations and requirements around usage of commercial UAVs made it extremely hard for companies to adopt these technologies. Even though they wanted to use drones, they were unable to, and that made it very hard for us to grow. We had to think really hard and refocus our limited resources in order to survive. What made the difference was for us to find the right problem to solve and to work towards a solution that's better than anything that had ever existed. So construction, mining, agriculture, inspection were some of the industries that we worked with. But drones are still a new thing, and the true value of what it can provide weren't fully understood by a lot of these industries. So we chose to focus on construction. Why? Because this was an industry that had already used high accuracy data, but their existing methods of acquiring this data was very slow, expensive, and not easily accessible. While CAD has replaced the design portions of construction, the actual building phases are still a very analog process. Only recently did the concept of BIM, or Building Information Modeling, become an adopted process in the construction lifecycle. It's a process that not only models the physical 3 dimensions of a building, but also the 4th dimension of time, a 5th dimension of cost, and so on, providing a rich simulation from the beginning of the job to the very end. So this has allowed massively complex projects to be simulated on a computer and carefully plan every aspect of that process to resolve errors before they happen. But simulation and planning is only half of the solution. As construction progresses, the state of the project must be captured and brought back into BIM in order to correlate what was actually done to what was planned. So tools like terrestrial LiDAR scanners and survey-grade GPS rovers, they exist today, but they're still very expensive and cumbersome to use on a daily basis. So drones turned out to be the perfect tool to capture a construction site from the sky. But the problem there was that it's not as simple as just taking photos of a job site from above. We also needed accuracy. Every construction site depends on it. A mistake of a few centimeters can end up costing millions of dollars to fix. So what is accuracy, and what does it mean to know where something is? I think back to my childhood, long before Google Maps, long before GPS. When I wanted to know where I was or where a certain address is, I had to pull out a paper map, look up the street in an index, find a grid number, look for that grid on the map, and then finally look for that specific street within that grid. This was a very tedious process that eventually yielded the understanding of where I was to maybe a couple hundred meters. So today, what we've developed at Skycatch is a system that can be quickly deployed, capture aerial photographies of an area, and then turn that into a 3D map where every single point is accurate to within 5 centimeters. So to create 3D models from aerial photography is not a new thing. The math behind it has been around for hundreds of years, and the process of using aerial photos to calculate 3D geometries have been done by hand ever since airplanes were invented. So why is our system special? We spend years building our computer vision software to do the 3D reconstruction, but that wasn't really the hardest part. So the core of the problem is still a question of where. For us, it was knowing the precise position of the focal point of a camera at the precise moment the shutter is open. So it became a problem of knowing exactly when the shutter was open and exactly where the drone was and the attitude of the drone at that very precise moment. To know where that drone was, we needed an extremely accurate GPS receiver. The GPS in your phone can tell you where you are to maybe a couple meters, but what we needed was centimeters. So to know the position of a drone on Earth to a matter of centimeters, we have to make very precise measurements all the way out to space. So GPS is a constellation of 24 satellites orbiting the Earth at a distance of about 20,000 kilometers. And each satellite is transmitting an encoded signal at 1575 megahertz. So that's a signal with a wavelength of about 19 centimeters. So for us to precisely measure where that drone was, we needed to measure exactly how many cycles of that 19 centimeter wavelength is from the antenna on the drone to every visible satellite. So that was the level of accuracy that construction demanded. And by achieving that and making this extremely complex chain of measurements as easy to get as clicking a button on an app, we slowly started to disrupt a very traditional industry that's slow-moving and very resistant to change. And the more that we work with construction companies, the more we understood the workflows and processes involved, the more we realized how valuable this data was and how big of a gap there really was in the availability and the access to this information. So in construction today, errors and rework due to mistakes are just an accepted part of that process. Budgets are designed with these costs built in from the start. Imagine if you hired someone to build a website and they had to charge 20% more because they wanted to account for mistakes they make along the way or having to redo parts of it later. So all these problems can be avoided only if there was an easier way to provide visibility into real-world progress and accurate measurements on the physical world on demand. Thus, we made it our mission to develop technologies to digitize the physical world in high resolution and accuracy. And by making this information easy to acquire, these real-world processes can become more efficient and error-free. We were successful in picking an industry with a hard problem and a real value in the solution. And then we try to push the solution as far as we can with the best technologies available. So just because that we reached a 5 centimeter accuracy doesn't mean our work is done. We're just starting to see what is really possible, and we're shooting for even higher levels of accuracy on the sub-centimeter and millimeter level. And we continue to push how fast we can turn this data around from the moment to capture to the moment that you can take measurements digitally. So our vision is to create a real-time and digital version of the physical world. So I know it's still a far ways off, but now I can see how we're going to get there. Thank you.